So guys, looking at this DT graph here, only just given this image and just this brief little piece here, you need to be able to explain what happened and give some, not just some qualitative information, but some quantitative information. So not just some like descriptive words, but some numbers to go along with it. So he walks along a straight road every day from his home to the bus stop. Bus stop is 160 meters away. So we can say that he walked towards the bus stop, all right, at a constant speed for 100 meters. So he walked 100 meters towards the bus stop. We can even say at a constant speed. Then he turned around. All right, if I look at this here. So right at this point, right, he turned around and walked back towards his home. And he did so, he went from 100 to 40, which is a total of 60 meters. So that's where we get this 60 meters backwards. Then what did he do? Well, then he walked from 40 all the way up to 160. So how far is that? You take the difference, 160 minus 40, which is he walked forward 120 meters at a quicker pace. Till he reached the bus stop. Because the bus stop is at that 160 meters. And then what did he do after that? He waited for the bus for how long? Let's see. He stopped here, which is at 100. And then to here, the graph ends at 120. So from 100 to 120 is going to be 20 seconds. Okay. Good. So now what may be beneficial for you guys is you need to be able to figure out sometimes the total distance that an object travels. So we kind of should have somewhat of an idea just by looking at what we had just accomplished here in number 1. So from here, you started at 0 and you go to here, 100. So you just moved a total of 100 meters. Well, then you changed direction, you walked backwards. We said you walked backwards 60 meters. And then you walked from 40 meters up to 160, and we said that that was 120 meters. And then you didn't move. So because of all of that, all right, if I asked what is the total distance traveled? Total distance would be just adding up each piece of that. So how far did you actually travel?
280 meters.
Good, 280 meters. All right. So if I ask you, like, what is the average speed of the whole trip? I don't know if I do it down here. All right, average speed of the whole trip is the total distance divided by the total time. So we're gonna right off the rip answer letter F. So if our total distance was 280 meters, how long did we move for? How long was this whole trip? 120 seconds. So here, all right, the total distance was 280 meters divided by 120 seconds. And we're looking at 2.3 repeating. So just cut it at 2 decimals, 2.33. and the unit will be meters per second. Boom. All right, so that's the average speed of the whole trip. So now what we're looking at, or now what we're looking to do is, now we're going to start calculating velocities. Now remember, velocities are essentially speed with a direction. So direction is going to come into play. Positive will basically mean you're walking towards the bus stop. Negative would mean you're moving back towards your home. So I give you guys line segments here. All right. So calculate the velocity from 0 to 50 seconds using this equation. It's kind of like what we used yesterday. It's final position. All right. Yesterday we used final distance minus initial distance. Well, x just means your point on the graph, right? Position-wise on the y-axis here. So at 50 seconds, what is your final position? You're at how much? You're at 100. All right, so basically, right, if you went to let me go to drawing shapes. At 50 seconds here, where are you? If you go straight up and then across, you're at 100. So that is your final position. And then your initial position at 0 is just 0. And how long were you moving for? Well, 0 to 50 is 50 seconds. So literally, our equation is going to be 100 minus 0 divided by 50. And that's going to give us 2 meters per second. All right, so very similar to exactly what we did yesterday. Now, the next one, though, is just going to be slightly different because now I'm asking from 50 to 70 seconds. So what is the final position? XF is going to be wherever you are at 70 seconds. So if I go to 70 seconds, right, where am I? I'm right there. And then if I go across, that means I'm at what position? How many meters? 40. Good. So I would say my final position here is 40. And then where was I at my initial position, the initial time frame here? So where was I at 50 seconds? So do the same thing. I go to 50. I go straight up and then go across. Where was I? Good, 100. So again, using the equation, it's XF minus XI. So final position minus initial position. So we got 40 minus 100 divided by how many seconds? Well, 50 to 70 seconds is how many seconds? 20. So we got 40 minus 100, which is negative 60. Negative 60 divided by 20 is going to give us an answer of negative 3 meters per second, which should make sense because we turned around. We changed our direction. So you see how the negative works with the direction? All right, that's why velocity, it's important to make sure you're using this equation when we're looking for velocity in particular. Okay, then 70 to 100 seconds. So at 70, we knew, where are we? We're at 70, we go up to 70 and go across, we're at 40. So that is where we are initially. And where do we finish? So go to 100 seconds and go up, we're good, 160. So here, we're at 160. So that means it's XF minus XI, so 160 minus 40, divided by how many seconds? $70 to 100 is 30 seconds. Okay. So 160 minus 140, 120 divided by 30 should give us 4 meters per second. Now, I don't have the positive written there, so it's kind of understood that it's positive. All right, meaning good. Yeah, you're going in the correct direction. Going to the right or going forward, however it is kind of talked about or initiated in the beginning of the problem. which makes sense. And then calculate the velocity from 100 to a 120. Well, at 100, you're at 160, and at 120, you're also at 160. So, I mean, you don't necessarily need this equation to figure it out, but we're just going to do it anyway, just for this. So it's 160 minus 160 divided by 20 seconds. So 160 minus 160 is 0. Anything divided 0 divided by anything is 0. So your average velocity there is 0 meters per second. Now what it wants you to do is calculate the average velocity of the entire trip. Now remember, average velocity is the total displacement divided by the total time. Okay, do you guys remember what displacement fully is? Displacement is pretty much, right, your change in position. So what is his net change in position? How far is he from where he started? Where does he end versus where does he start? So if you look at the graph, he started where? 0. Where does he end? Up here, right? Does that make sense? So if I do this, he starts down here at 0, and he ends here at this point because he's not moving, he's not changing his position there. So he's wound up being a total of 160 meters away. That's his displacement. He went from his house to the bus stop, which is 160 meters. Even though he had to like come back for a little bit and then go, so he technically moved this total distance, which we figured out in the beginning, 280 meters. But we don't care about that because displacement doesn't really depend on your total distance. It's just how far you are from your starting position. So we said we are our delta x, which is our displacement, divided by the time. So 160 divided by how long were we moving for this whole thing? 120. And so we're looking at 1.33 repeating, so just call it 1.33 meters per second. All right, cool. Got it? Sweet. Okay, so just guys taking now a look what we're going to do next. We're going to be looking at speed time graphs, different from our distance time graphs. So on this, you got to pay attention. The y-axis is different. It's no longer distance or position on the y, it is speed. So a flat line on the other one meant we were not moving. On this, that means we have a constant steady speed. Here, if we started our speed down at 0 and we get up to, let's say, 10 meters per second, well, we've increased our speed, so we are accelerating. If we started up here at 10 and slowed down to 1, we decreased our speed, so we're decelerating. Okay, these are showing two forms of acceleration. The checkered line is moving at is accelerating quickly, right? More quick than the solid line here. So accelerating, constant speed, any point like this, constant speed, right? Constant speed, assuming I can make a straight horizontal line. So those would all be constant speeds. What would it look like if it wasn't moving? It would have to be down here at 0. It would have to be flat at 0. All right. Again, you have to pay attention to what's on the y-axis. So if right there is 0 and you have a portion of the graph that is there, yeah, you're not moving. And then you could wind up having a negative velocity, which means it would go underneath, all right, the x-axis. It would go past there. So we're going to take a look at that next in our assignment here. All right. So we have a velocity time graph. We have meters per second, and then we have seconds. Now for acceleration, the unit, guys, for acceleration is going to be meters per second squared. Just keep that in mind. All right, so if we're looking at this first piece, and I asked you guys, hey, what's the acceleration from 0 to 2 seconds? All right, here's the equation. Final velocity minus initial velocity over time. So the same principle as we were just dealing with, but now instead of it giving us our speed or velocity, now it's giving us acceleration when we do that. So what was the initial velocity? So at 0 seconds, what was my speed? So go to 0, go straight up, and go across. Where am I? I'm at 10. Okay, my final velocity. What is my velocity at 2 seconds? So go to 2 seconds, go straight up until you hit the slope, and go across. I'm at 10. And how long was I moving for? 2 seconds. So literally, oh, the acceleration is VF minus VI over T. 10 minus 10 is 0. 0 over 2 is 0 meters per second. And then to do squared on a Google Doc, you'd have to hit control period. If you hit control period, your cursor will jump up, and then you can put your little squared guy there. And then you'd have to hit control period again to get back out of it. Okay. So now, how far did we move then? How far did we move then? So to find the distance, you're going to use this guy here. All right. Pretty much take these two guys here, VI, VF, times it by the time you're moving, and then cut it in half. So if we had initial velocity of 10, we had a final velocity of 10, 10 plus 10 times how long we're moving for, 2 seconds, and then divide by 2 at the end of it. So 10 plus 10 is 20. 20 times 2 is 40. 40 divided by 2 is 20. So you moved a total of 20 meters here. Okay, so now we have to look at the acceleration from 2 to 5 seconds. Okay, at 2 seconds, what was my velocity? What is the initial velocity of this time, this time piece here, this interval? That's the word I was looking for. So at 2 seconds, what is my initial velocity? Go to 2, go up, go across. Where am I? 10. Okay, next one, VF. At the end of the time interval, which is 5, what is my velocity? So I go to 5 seconds, and I go straight up until I hit it, go across. Yep, good, 60. And then how long was I moving for? 2 to 5 is how many seconds? 3. Bam. So acceleration is VF minus VI. So we're going to do 60 minus 10. Then divided by T. Time was 3. So 60 divided by 10, or 60 minus 10 is 50, and 50 divided by 3 comes out to be 16.6 repeating, so we'll call it 16.67 meters per second squared. And how do I do this squared again? Control period. Bam. And if you ever needed to do a subscript, it's control comma. Just those are maybe useful because you know math or this course we're probably going to be using, if we use it enough, it's easier than sometimes having to go into the options and bibbity bop. Okay, so 1/2 VI plus VF times T. So just do VI plus VF. So we're at 10 plus 60 times our time of 3 seconds. and then divide it by 2 because it's 1/2. So 70 times 3 divided by 2, and we're looking at 105 meters as that distance traveled. Okay. So to find the distance of this, guys, is on a velocity time graph is technically its area under the curve. So if you notice this first one, 10 times 2, right? This is a perfect little rectangle here. 10 times 2, we wound up getting 20. Then over here you have 60. This is why like this equation is just better, because when you have something like this, all right, you'd have to do 1/2 the base times height piece here like that in order to get the triangle portion, and then you got to do the rectangle piece underneath here to get it all. But so this equation winds up working everything. Okay, then acceleration from 5 to 10 seconds. So at 5 seconds, what is my initial speed or initial velocity? 60. All right. Then what? What is my final velocity? Yep. We were going from what? 5 to 10 seconds. So at 10 seconds, what is my speed? 50. So VF is 50 meters per second. And how long were you moving for? You're moving for a total of 5 seconds. Good. And so it's VF, right? VF minus VI. You have to pay attention to that, because a lot of times what will happen is they'll get those numbers, but then just do 60 minus 50, and then your answer is going to be wrong, because remember that vectors are my fave. Vectors need magnitude and direction. And fave stood for what? Those are like the 3 most common vector quantities we use: force, acceleration, velocity. So acceleration needs a direction. So that's why it's important that you have to do it like this. So VF minus VI divided by the time. And we move for a total of 5 seconds here. So we got what? Negative 10 divided by 5. And we get a negative 2 meters per second. What is the unit for acceleration? Meters per second squared. How do I get the square? Control period. Bam. Okay, and then the distance is, all right, VI plus VF. So you add the two velocities together. So 50 plus 60 times it by time, which was 5 seconds, then divide by 2. All right, so that is going to be 50 plus 60, 110 times 5, 550 divided by 2, 275. 275 meters. Now, if it add here, it just asks you guys to find the total distance traveled. So it would be adding those 3 values together. All right, so you're adding 275 plus 105 plus 20, and you're going to get a total distance of 400 meters as your total distance. Very nice. Okay, so now we got this dude here. So let's see. What time is this object moving at 0 meters per second. So what time, there may be more than one, is the object have a speed of 0? Anyone? So this is not one of the questions asked there, but it will be a question you see on your test. What time or time intervals is the object not moving, or is it at rest? So good, 0 seconds, because right here is, this guy's right here is 0 speed, 0 velocity. So basically, if I went like yeet, so we have at 0 seconds, at 9 seconds. Is there anything else? And 14. Good. So that's not written here as one of the problems you have to solve, but that is a very good piece of information to understand. So now, let's just briefly explain what's going on. What are you doing here? You're going from 0 to 2. So did you increase your speed? Yeah, so you're accelerating here. Then you're going from 2 to 6. Did you increase your speed? So you're accelerating. Which segment are you accelerating better or faster in? The 1 to 2 seconds or the 2 to 3 second? 2 to 3, steeper the slope. Okay. What's going on from 3 to 7 seconds? Good. You're at a constant speed of 6 meters per second. And then what are we doing? Now we're going from 6 down to 0, correct? So we just did what? We decreased our speed. So we're decelerating. But now look what's underneath here. -1, -2, -3. So a question I want to know is, this segment right here, what are you doing? Are you still decelerating or are you accelerating? Just in the opposite direction. What do you think? So remember, the negative sign is just indicating direction. So from 6 to 0, you slowed down. But now you're going from 0 to 3, but you're doing it in the opposite direction. So this piece right here, you are accelerating. All right. So definitely you need to understand that just because it's negative like that doesn't mean necessarily, all right, that it is slowing down. So essentially, if it's going away from 0, it's speeding up. Now that depends on direction. This over here, it's speeding up, going away from 0 in the positive direction, so we have a positive acceleration. Down here, we're going away from 0 in the negative direction, so we have a negative acceleration. Wait. Now, VF minus AI. Again, yeah, no, you still have a negative acceleration, but you're moving just away from 0 in this case. Yes. And then here you would be slowing down because you're going towards 0. You're going towards 0. So you're at a -3, going towards 0, you're slowing down again. And then if you hit 0, that means you have come to a stop. Okay. So now let's complete these pieces of information here. So let's take a look at the first one. What is the acceleration from 0 to 2 seconds? Well, at 0 seconds, what is your speed initially? That's your initial velocity. Everyone should have no problem with this. It's 0. What is your final velocity? So what is your velocity at the end of this time interval? So at 2 seconds, what is my velocity? 2. How long was I moving for? 0 to 2 is 2 seconds. So acceleration is what is acceleration here? Excuse you. VF minus VI, so 2 minus 0 divided by the time. So 2 minus 0 is 0, I'm sorry, is 2, and then 2 divided by 2 is going to just be 1. The unit for acceleration is meters per second squared, which is, if I hit control period, gives me my exponent function, and then we can crank that one out. Distance, initial velocity plus final velocity times time divided by 2, right? Because it's the 1/2. So 2 plus 0 is 2. 2 times 2 is 4. 4 divided by 2 is 2 meters. So you move the distance there of 2 meters. All right, I want you guys to fill out the remainder of these. Now, remember that distance can't be negative. So in this last piece here, you just drop the negative sign. All right, so I want you guys to work on those.